Hello and welcome to my channel. In this series of videos, I'm gonna walk you through how I built a custom physics package in Unity ECS. I called it Little Physics. It runs way faster than Unity's built-in physics package for entities, but with certain limitations, which I'm going to talk about later. Also, you can speed up the simulation or even pause it. Little Physics supports the main type of objects such as dynamic objects, static objects, and triggers. There's also a gravity support, both linear and angular, so you can have normal downward gravity or something more like a planet pulling objects towards its center. Let me give you a quick overview of the pipeline. I'll go deep on each of the steps in the next videos, but this is a big picture. Every fix update, this is what happens. First, every dynamic object fills a 3D spatial map, basically a grid that divides the world into cells. Then, based on what's in each cell of the grid, an array of unique pairs is built. Then, intersections are calculated for each pair. Once intersections are found, the system calculates the collision response, linear and angular velocity changes, and adds them back to the object's current velocities. Surface collisions are handled separately. Rather than going through the spatial map, every dynamic object check for collision against surface object directly every fix update. At the moment, system might have only one surface per simulation. After all that, the system runs any user-defined operations, custom collisions, callbacks, additional forces, raycasts. Then it applies all the resulting velocities back to the object. And if your timescale is set to 2 or 4 times, this entire pipeline runs that many times in a single frame. The spatial map cells, collision pairs, and intersection results all live in persistent native data structures with random access. There are certain limitations to the system. First of all, dynamic objects and triggers can only be spheres. This simplifies the intersection math a lot. Secondly, there are hard limits on how many objects can be in a simulation and how many collisions can happen with one object in one frame. Users configure all of these themselves. This helps with memory management to predefine a size of all data structures. The spatial grid has fixed cell sizes and a maximum number of cells any single entity can occupy. The bounds of the space where collision check happens are also limited by that grid size. So that's the overview. In the next video, I'm going to dive deep into the spatial map concept. So please stick around, hit the like button, and I'm gonna see you in the next video.